Okay, so last time we programmed the following. We wrote a diamond, we looked at like RISC-V, and then have wrote this like diamond drawing function high level. This morning I want to basically make this way smoother, more efficient, possibly start translating this to RISC-V. We'll see how we get there. Another thing I want to do is just like draw a very simple disk and have that animating on the screen. Like I think that could look like quite interesting. Even though I don't think Brevis yet has capability for floating point numbers, I do want to get, we can still draw it, we can still simply draw a disk. But as I say this, I realize I do not have my iPad yet to see Twitch chat comments. I'm gonna go get that. I'll be back very soon. All right. Get this going, and then just here. Okay. Okay, all right. So let's get this working properly. No, not windowed, full screen. Okay. Okay. So, let's spawn a new. I also realized yesterday one of the reasons it was slow was because so many tabs were open in the operating system. So you want to do RISC-V, then get back into the codex, and then scriptor and edit diamonds. .lbc. Okay, and so I think both for this, oh, my capture card is failing. To get I need to adjust the screen. Why is the resolution of this so bad? Do I need to do it again? This is really bad. I think yesterday I kind of somewhat solved this by like running this thing, but I wonder if maybe I need to like delete this and add it again. Because my previous setup was to like link this with many monitors. Okay, this at least looks okay. Toggle full screen mode. Okay. this is better than what was there before. So, okay, I probably can like delete this, I think. I still have it here. Okay. So yeah, so currently we're just calling this procedure heaps of times, but there's a more sensible way of doing this. Namely, all of like the areas of the diamond that are of a single color have like the same distance range. And so as we go through the diamond, if we just calculate the distance between that point on the screen and the center of the diamond, we can then basically like move that, figure out if that radius is in like a multiple of something, and then color the pixel based on whether it's a multiple, like where exactly it lands in the band. So I'll do that. But this will require kind of re-implementing all of the, yeah, kind of like, well, we'll need to change what we're doing with the pointers and everything in order to do this. Okay. So we'll make a new version of this procedure now. I think for this we only really want a top pointer, possibly. Yeah. And then for this part here, we now want to calculate like the distance between like the kind of pixel and the center. I think in this step, since we're doing everything with integers and not even with floats, and the geometry is simple, I think we can just calculate this geometry by having some arithmetic function, some like algebraic function of the i's and the j's. One thing we could do is rewrite like the counters for the i's and j's to make this easier. Like we could rewrite the i's and j's relative to the center pixel. And then in such a case, we would just simply want to add them to get like the kind of the distance in some way. Yeah, I'm kind of feeling that's what should happen. So let's modify this then. Modifying this will mean we modify where the start point is. I think it should be fine. Okay, so let's kind of start from outwards and kind of work our way in. So we'll want to start with from let's actually start the memory one cap. Let's start from like the bottom radius. Oh, we can't. radius is not a... It's fine, it's fine. I'm going to go from like the bottom upwards, and then the line start pointer. See, if we're now starting from like, no, I don't like this. I don't like this. How do we modify this? I think instead of top pointer, we just want like the center pointer. This will enable us to get rid of both of these variables as well. So relative to the center, the start is going to be we first need to go down I many screen lines, which will be a multiple of, like, which would be like the number of kind of colors, which are 4 bytes, and then so we need to multiply this by I, then we need to do the offset, and the offset will be I think it needs to be like the absolute let's see, when I equals 0, we're going to be subtracting the radius. And when the I is the radius, we're going to be subtracting 0. So what is this? We want this to be like the absolute value here is like, it's being annoying. Now I'm even thinking, does it make sense to just go from I being negative the radius to the radius? Should we even move to like a 0 or 0 to 2i scheme? I don't think, like the 0 to 2i scheme would enable us to, what would we do? Maybe absolute value is the way to go. This is when I want like the zig intrinsic, like absolute value or something. say we did just have the absolute value, we can code that later. Then we would just want to have, like, starting on the center, move back the radius, and then add on the absolute value. Yeah, okay, that's simple. So now, can we do this without, like, can we do some smart trick that doesn't use some instructions just taking the absolute value of I? I'm not seeing it. Okay, so let's have S32 absolute value of I is equal to what's like the hacker's delight way of doing this? I should just like look it up. Hacker's delight assigned. Right, this loads. Do we want to use any of these, or should we just use, like, since this is like RISC-V, I'm not even sure what like the kind of cache level is. I'm not even actually sure if there's like branch predictions and stuff, and if not, we can just use like an if statement and it'll be fine. It'll be like two, like three, like at most two other instructions, I think. I see, yeah, so this is just saying get like the very first bit of x, which will be 0 if it's positive or 1 if it's negative, store that in y, and then simply do the following. Any of the following would work. Yeah, I feel like the if statement is actually fine in this case. Like maybe when we get to assembly, like we can do something else, but it's fine. So we can just say C actually we can see if this is a negative, we'll just make it equal to okay, and then so now we want to subtract the radius and add on the absolute value. I should say this maybe like I doubt RISC-V has like an absolute value function. We can check. Like I don't remember this being in here. That's fine. I mean, like how bad would this be? Like one instruction to get the kind of like the last bit, then another instruction for like the XOR, and then another instruction for that. So it is kind of 3. Actually, maybe it's alright. Okay, I think we will end up doing this. Okay, and why does this work again? So let's say it's like -1. So X is all 1s. The final bit is of course a 1. So then Y just becomes like 0s and then a 1. This will then like flip everything up to kind of 0s, and then no, that will, if it's XOR, it will like make the first one 0, everything else 1s. Then when we subtract -1 from that, wait, what? Why would that work? We then have like -2 minus -1. Like if it's the X plus Y case, then like this one this one is like, it's clear to me why it works in this case. It's like every bit is 1, add 1 to that, every bit becomes 0. Then and or XOR to like that bunch of zeros, just like the 1, -1 becomes 1. And let's say it's like absolute value of 2, then yeah, the final bit is 0, so that doesn't do anything to it. Yeah, I like this, like the second one is like obvious to me why it works. This first one, it's not so clear. And yeah, let's see, so X is like, if X is in general some like larger number, then wait, no, this still isn't. Say X is some like negative number. Like what should it be? What should this be? Like if it's positive, you clearly don't want to do anything. By definition, nothing needs to happen to it. But if it's a negative number, what do you want to do? I don't want to like start writing this down on paper, which I feel like I would need to. but I want to convince myself that it's true. Okay, so now we have that. We now want to do like let's just start by just like drawing everything without doing any distance. Get rid of this. Get rid of this. So the pixel location is, the pixel location is the line start pointer. Once we've added in, yeah, so now I'm just like thinking, do we even need to, offset it like back just to go forwards? Like this feels unnecessary. I think like I just want to have like, I want to just find like the center, or like the line center pointer. And here we're not doing any of this radius stuff. And then here for the actual location of the pixel, this is where we want this stuff. We're going to need to adjust j as well. So we want to set j equal to -I. And then we just want to go I think we want here j is the radius minus the I, or rather, it's like the radius minus the absolute value of I. And then provided j is less than like the amount that we're creasing in the line each time is just governed by, yeah, it should be the, we want to go from the radius minus absolute value of I to like the radius plus, no. Like, what should j be? J should just be the offset from the center. So actually, if we just care about the offset from the center, yeah, the offset from the center is going to be bounded, and it's bounded, the lower bound is like the lower bound needs to like start off from 0, increase to the radius, and go back to the 0. Yeah, so the radius minus the absolute value of I should be fine, since I itself is ranging from the negative radius to the radius. But in terms of the upper bound, we need j to be something's not right. I should just be like drawing this out on a diagram instead of doing this in my head. It would be way faster. Do it in my head. It's fine. The diagram would be so much faster. Okay. Do I have a GIMP on this system? I do. Good. Yes, whatever. This new thing. Give me. I don't know why we have that color. Where's the drawing thing? Okay, great. No, GIMP, I just, no. Okay, let's just figure this out the easy way. So I want to just think about this as I going from, it's like 0 here, it's the negative radius here, it's the positive radius. I should have done this at the beginning, it's so much easier. Likewise, I just want J to be 0 here, the radius here, and the negative radius here. So then the question is, how do we like calculate the pointer in the array for anything within this grid? Well, yeah, let's say it's like some point here. We need to go back. So the other thing is that I'd like for every single pixel calculation, I don't want to have to do like the entire pointer calculation again. This would be using too many instructions, I think. I think it would be simpler to just, yeah, like find like, do the calculation that gets like the start of the line and then just like moving across. And then we're just like incrementing things by 4, which is a single instruction, instead of all of these lookups. Like, I guess things have been optimized in like x86 that you can do like the lookup and it's almost the same, but this is RISC-V. Okay, so really the place we should be looking up is not there, but we're just like looking up the center. We've already done that calculation. And so from the center, how do we determine how much to go back or forwards by? Adding stuff by 4 is like the easiest. Like I think there's like there's this optimization constraint that we need to pay real attention to. Then there's like the easy mathematical way of doing this, and the two are not compatible. If this were a shader, they would be, but this is not. Honestly, maybe just calculating like, given that like it's easy to go across by adding 4 each time, perhaps we just really should be calculating the thing here. I feel like this is actually the way to go. because in this case, j is just like going from the offset, is going from 0 to, well, what? It's dependent on I, and it's going to be, we just like want to calculate the width of this. The width here is like 2 times the radius, the width here is just 1. So I feel like the width should just be like 2 times the radius minus 2i plus 1. Okay, this is I think this language will do this calculation each time in the loop unless we like save it. So we'll save that as a separate thing, use that for the loop to compare. And then, oh, but when I say I think I really mean that. Which is fine. It's some like extra constant calculations each time we go through this, but it's like when we go through it vertically, not horizontally. Okay, so then it's just a matter of actually finding the pointer to the beginning, and how we doing this? I guess we want to do the old thing now of like just find the center, which is going back multiples of the screen width, and then doing the same kind of thing. The thing we had before, like subtract the radius and then add on to it the absolute value of I. Okay. Okay. I should have just done that at the beginning. Okay. Time to rewrite the line center from like so yeah, the line start pointer is just the multiples of the I minus the radius plus the absolute value of I. J here, we're just iterating from 0 to, what do we have? 2 times the radius. Minus the 2 times, so it's really 2 times the radius plus the absolute value minus the absolute value. And we want to add 1. And the condition is that j is less than, oh come on. J is less than this thing. And then, yeah, the pixel location is just that and just that. Okay. I feel like this won't compile. Let me read through it to see what the error will be. So let's see. Let's say the radius is 1. Then we're going to have to do like 3 horizontal draws. at I equals -1, I equals 0, and I equals 1, that would then work out. Likewise, if the radius was 0, it would just draw like a single pixel. I guess that's not actually what we want. Not really. The off by 1 error. I feel like the time to fix the off by 1 error is now. No, it's easy. If the diamond is 0, we just won't call it. Okay, this is fine. Then set it to be that, and then here's a bug. The parentheses here are incorrect. So I think they should be fine now. Okay, and then so yeah, let's just do this case where we're drawing like the kind of 3 by 3 diamond. So in this case, we're setting I to be, we're setting the radius to be, I guess to be 1. So then j is going from, when I is -1, the radius j should just only equal 0. And we're saying 2 times the radius minus, which is 1, minus 1, which is 0 plus 1. So yeah, j will only get called there once. When I is equal to 0, we want 3 values of j. This would give us radius, which is the 1 minus the 0, which is 1. So we get j is less than 3, so we get 3 cores. Okay. And then the start here is just the point arithmetic for that, and we set that to be that. Okay. Hopefully no compile errors, but we'll see. So we want to do compile in the codex the file diamonds.lbc and write this to productor diamonds. Okay, I knew it. I knew it. I don't know of anything called S32. Huh? Why not? guess because it's not a type yet. So it should be an S64 anyway. What? Okay, I did get the brackets wrong. So first we do the I times the thing. Oh yeah, I need to add in more brackets. Let's just put like spaces around them. Like, yeah, there needs to be like, oh, I need like the syntax highlighting. I guess I should just put another parenthesis around this will work. Like maybe leaving it like this, it's a bit clearer now. So now there's like 3, and so we just need to count 3 on the other side. Like 1, 2, 3. Okay, that's at least compiling. Okay, so it is drawing it using the new one, and it's doing its thing. Okay, so that's still working. Good. It's working as expected. Quit out of that. Back to the editor. Okay, so now I want to do our like distance stuff. So I'm going to say calculate the distance from okay, so it's not completely obvious since we're like the J is not iterating in the easy way, but it should just be the absolute value of I plus like yeah, in order to like get these gradients, we just want to do, let's just go back to the diagram. It's easier. How do I like clear everything? Let's make a new layer. So yeah, all of these things are like a constant of like the absolute value of the x plus the absolute value of the y is equal to some k. And so we just want to do this. The I is fine. We just take the absolute value of the I. We've already done that. For the y, since the y is the k, which we're altering from like 0 to like something, and the actual position of it itself is changed. Yeah, this is why I'm like the J. It's easy for the J to just like, anyway, we'll stick with what we've got. So we need to calculate like the y difference from the center. Now, so this is going to be we might have to do like another absolute value calculation. Ooh. I I almost want to just like abandon the thing I want to do is the disk anyways, but I kind of want to just like abandon this because like I'm not having fun at all with this. In my head I was just like, yeah, you just like do the distance and then divide it by like the radius, check if like the parity of the first bit, and then assign a color, and that's all that's needed. And then just coding this up, I'm like, ugh, it's a headache. It's like, yeah, the question is like where in this, there's like, I think we still want to do like the add by 4 when we're iterating across these lines, but it would make the most sense to just have the J iterate in like the sensible way. No, but like I think we're just gonna like do the disk. Like programming the disk to draw the disk is so much easier than all of this like color gradient stuff I'm doing. This is like the complexity level has been breached. We're gonna just like let this sit and do the thing I actually wanted to do. Okay. So let's just start programming the disk. So we want to do scriptor the disk. Like yeah, like with some like it's with some less friction, like I'm using like a Dvorak keyboard, other things, it would be fine. Like I was using Emacs, I would be fine, but it's just there's a bit too much friction here for me to be doing this kind of thing. So with this level of complexity, so we'll go back to the easy thing. So yeah, let's just, when we're drawing the disk, we'll just use the radius to begin with. And the only line I really need not to delete is this top pointer thing. Maybe the fact that we're casting stuff. Okay. Okay, so back to the diagram. Let's do yet another one. Okay, so how are we doing this? So we're not doing any like i's and j's that depend on each other. We'll just like iterate through a rectangle, and at each point we want to just like calculate whether the distance is within some like integer bound. Okay, so it's kind of inevitable that we need to find some coordinate. Like it's already like the storing the pointer, it's like already the optimization work just begins immediately. You have to think this way. Like in a similar way, the easy math way is just like you iterate from like negative the radius to the radius, and then from the negative radius to the radius here. But you don't want to have to do the pointer lookup calculation at every single thing. So instead, we'll just do it like once per line at the beginning of the line. And then but should it just be the center? Like what's the simpler? There's this whole thing between now like this like the number of individual instructions. Like multiplying something by 4 is just like an extra instruction because we're just shifting. It's like this would be like the left logical shift intermediate by 2. Where should we do like the line pointer calculation? In the center or on the side? That's the first thing to decide. So if it's in the center, we can just find the pixel offset by just saying like the value of R. Okay. Option 1. Take the value of R, multiply it by 4, add that. Doing that requires like an extra multiplication by 4 instruction. The easier thing is by thinking of R as multiples of 4 to begin with. Then it's just like add R that's already been multiplied by 4. And then when we're incrementing R, that's when we just add in like the extra 4. Okay. So we actually want R itself to be the negative 4 version. So we want to go R is like negative 4 times the radius, negative 4 times the radius minus 1, etc. But I suppose it would make it actually more, it would be nicer to consider it as negative 4 of the radius, negative 4 of the negative radius plus 1, all the way up to negative 4 radius. Okay, good. We've saved ourselves some instructions. And also it's at least simple to go across. But we're also doing this without floating points yet. Like with floating points, we'll be able to like scale the disks arbitrarily. If we're just like interested in just drawing a disk with integers, we can like factor this like for, we can factor this 4 into it. we'll just like draw some disk if we're just making this like this kind of like tech demo, but there's it's like including like basing the code around this number 4, it just feels a bit weird, but then we're optimizing this, so maybe there's no other way. Okay, so then in order to calculate, okay, so at least with this system, getting the pointer value of the place is easy and doesn't waste too many instructions. Because we're just incrementing it by like 4 each time, which is like, you know, adding an immediate of 1 is the same as adding, the cost of adding 1 is the same as the cost of adding 4. But now we need to do like the distance calculation, and so if it's the disk, before we consider the multiplication by 4, if it's the disk stuff, we just want to do the kind of like, you know, the dx squared plus the dxy squared, and just compare if that is less than or equal to some number n. And then that will give us a disk, or not smooth disk because we don't have floats yet, so we can't do grayscale stuff, but this will work for the moment. Vertically, we just do r squared, that's easy. Horizontally, since we're dealing with these r's as like the multiples of 4s, we really should be like factoring this into all of this stuff. So if instead we multiplied everything in this equation by 16, we would then get that would then like enable us to square this thing, and then we get like the 16r squared here. I should really call this like r1 and r2. Then I realize this is probably making no sense to anyone but me. Let's just clear it again. I can do much better. Okay. So we have dx values here, and we have dy values here. At the center, these dx values and dy zeros is 0, 0. The dx range from negative r to r, and the dy range from negative r to r. Okay, in terms of the pointer calculations, what we're actually keeping track of is I should just assign these variables. We're keeping track of some variable I, which is going to remember the values, which like I is remembering like 4 lots of the dx. In other words, it's taking values within the negative 4r, the negative 4, no, we're doing it for negative r, for negative r plus 1, all the way up to 4r. But the j in this case is the j, no. We won't change conventions. The j here is the thing that's taking values within. I think the j, we just want this to equal to the dy. So now the question is, using like the I and the j, how do we do the distance? Or at least, how do we use the I and the j to give us some like determination? So what we actually want is, like, the thing we think of in our head is dx squared minus dy squared is less than some n. But the fact that the I here is a 4dx means what we basically we need to multiply everything here by 16. And then the 16n, it just becomes like n tilde now. And then the 16 dx squared is now just I squared. And so now to do like the 16 dy squared, which is the j, we just want to do, I guess it's there's two things. We can either like multiply the j by the 4, then square it, which is 2 instructions, or we can like square it and then multiply it by 4, which is also 2 instructions. So we may as well just do multiply the j by the 4 and then square it, and then we do like the bound, and so now we say like, is this what would be a bound to choose? Let's say at the beginning we're just constructing a like circle of radius, let's say radius 10, then the n, usually this is like an n squared, then well, why am I using n? It really should just be r. Yeah. So then say we want r is equal to 10. We'll see if the Serenum can handle it. I think it will be able to. Then, you know, n squared is 100. So then we want that constant there to be 1600. Okay. Okay, so then going back to here for the draw disk. Top pointer is vague. Let's call this like top left pointer. For this, we want to go to like negative radius. So we want to do y. Instead of going down y versions, y frame width, we want to do y minus the radius. I keep on calling this radius, we just call this rad. It'd be quicker. And then there's like the parenthesis issue again. What did we decide last time? Just count them. There's 2 here. 1, 2. So we kind of need a 3. And then plus the top x here. Again, we need to minus the radius. Let's see, 3 radiuses here, 3 brackets there, 1, 2, 3. Okay. And then now I have to do like the I's and the J's and everything. So we should just begin the loop. So we're setting I here to be negative for lots of the radius, and we want to continue to do this loop so long as I is less than 4 times the radius. Hang on, since this is like a loop, we don't have that final parenthesis here. We want to actually exit. We don't want this to be an infinite loop, so we need to increase I by 4 each time here. I need the Dvorak keyboard on this operating system so much. Okay, and then we need to like keep track of the J's. So likewise, we want another loop. And likewise, in this case here, the J is just going from the negative radius up to the radius up to that. Hello, hello Heidi Brooks. This is a programming language known as Brevis. If you want more details, if you go to samhsmith.com and you go to this Serenum Release 3 Programming Basics, this basically tells you the kind of language. So yeah, the programming language is called Brevis, and yeah, it's a programming language basically in Latin, and yeah, it works. The only way to get the compiler for it is by getting a custom computing system known as the Serenum. The Serenum is like is Sam's solution to Casey Muratori's 40 what's it called? The million line problem. There's like a number attached to it. Anyway, it's basically like a new computing design from scratch that has no drivers whatsoever. It has like a more sensible security system. Yeah. It's like I'm just learning about it, testing it out, improving the product. Okay. So yeah, so now J is going from negative radius to the radius. So according to diagram, we want to look up we want to do like the memory location first. So that's going to be well, first of hang on. Like given that like in every iteration of like the line loop, we need to do like the pointer calculation anyway, I don't exactly see the point of like doing like another pointer calculation relative to this one when we could just be doing it like at once. Like all I need to do in this case is replace the I was gonna say replace the rad with like I, but since we're multiplying the I by 4, we kind of will need to do something different. Okay. It's fine. So yeah, so let's do we want a pointer, so let's just call this like line start. And for this, we just want to do the top left pointer. But we now need to offset this by no, I'm like, okay, I'm getting like the I's and the J's here completely wrong. This is embarrassing. Like there's even this convention of like, should the I's by default correspond to like going across or by going down? I feel like they should just like follow. For me, like I want the I's to be like going across and the J's to be going down. So actually, so let's like move. We need to like do another outer loop anyway. Okay. And so, okay, we can actually do this single point idea I had. So yeah, so we want the J to be going in this. So likewise, we just want to we want to increase the J by 1 each time. And each time we do this, we can just do like the pointer calculation that gives us the line. So we want to we want to. Oh, cool! Yeah, cool that you're a graphic designer. Cool. Studying IT. Yeah, lots of skills. Yeah, I think like there are some graphic designers who do kind of like tech programming kind of stuff where oh no, okay. So I'm like finding like dealing with this editor and talking at the same time and trying to program too much. Because yeah, this text editor doesn't yet have an undo, which is a thing. So yeah, so we want to say, let's like I should just write all of this from scratch. It's easier. I will now be like the top level loop, whatever. So I is which is an S30 and S64. It's the negative radius, and then provided that I is less than the radius, continue to do a loop. Each case in the loop, we're adding 1, and we're going to look up the we need to figure out the memory address of the first pixel that we're going to be updating. So I could say line start pointer. So we get like, we have the pixel buffer, we then want to add to this the y coordinate of the center plus the I, multiply that by the frame width, then and then subtract 4 times the width from that. Oh, hang on, we're not, no, it can just be, yeah, it can just be the radius in this case. And yeah, and then we're multiplying everything there by 2. Yeah. I mean, like, yeah, potentially, like, I could design something for my stream. But I think for the moment, I'm doing many projects, and the streaming for me is just like a fun thing that is supporting one of the main projects, but it's just, yeah, I'm not like that into it yet. But we'll see. If in the future I have like some decent following that Twitch is giving me money, then yeah, certainly I would invest in banner design. But for the moment, no. Okay. So yeah, calculate the Y position, move back the frame width, then go exactly back by radius, multiply the result by 2. Let's see, I see 3 parentheses here, and then like the 1, 2, 3. Okay, that's fine. So now we need to do the other loop, which is, this is where like this like multiplication step by 4 comes in. So here we want to say, define the j here to start off with negative 4 times the radius, and we want to go all the way up to I guess like we want to go all the way up to 4 times the radius. And then okay, and then we need to do yeah, if you want to like I mean, I have like my most of the coding I do is on GitHub. The stuff for the Serenum is not, because it's like a closed ecosystem. But yeah, if you like check out my GitHub page, there's like an email there that you can use to contact me. Like I think you need to log into GitHub, since it's not like GitHub doesn't show the emails by default. But once you've done that, it will be there. Okay, so now we do. Okay, so now we're gonna be like adding. Oh no. Yeah, we're adding 4 each time, which is actually, I think I have somewhat complicated this. Yeah, I think I have unnecessarily complicated this. We can just continue the J to be like this. Because each time we go to like the next pixel, we're just like adding a constant of 4. So it's actually fine. I'm not sure. Yeah, I'm not sure what this was. Okay, and now likewise, so now we want to do the prolada. Oh, now we're running into this issue again. I guess it is fine, just each... Ooh. Like, do I want to increment... I'm seeing the issue again now. Because like the j is being used for many things here. We need to do it to do the distance calculation. And wait, why can't I just say j is like this negative radius? What's the problem? I think the problem is that I need to like update the pointer every time we go through this loop, but that's fine. But then I also need to update j as well. So maybe this is the thing. I was just like, if we're increasing j and we're like, if there's like two things that we're increasing, this feels like more confusing and inefficient in some way. But I think it's easier if we just increment the pointer offset manually by 4 each time, and there's so many options of how to do this. What's like the simplest and fastest? Like we're gonna have to have one instruction for changing the memory. That's always a given. And there's gonna have to be one instruction for like altering the j in some way. And then we're gonna have a couple of instructions for the distance calculation. So so if the instructions for increasing the j and the memory counter, the memory position are themselves like different, and they kind of have to, like there's no way to make those one and satisfy this condition of doing the distance calculation. So we may as well just have something separately that increases, like why am I like feeling weird about this? I feel like there should be, I guess it's because all of these things are like interdependent. But yeah, I think the easiest thing is just increase the memory location by 4 each time, increase j by 1 each time, and then just like do the calculation. Maybe in my head I was thinking like you increase the j and then you set like the memory to be like the j offset. But again, that's like, those are two separate instructions, so it's okay. We'll just make, j like the easy, going from the negative radius to the radius. Each time we're increasing it by 1. And then we have to do like, well, there's actually two things we're doing at the end of each of these loops. The first thing is that, and then and this says like line start pointer. It could honestly just be like pixel pointer, and we just increase this thing itself by 4 each time. There's like less variables to worry about, easier to translate in RISC-V later on. So increase j by 1, and then just increase the pixel pointer by 4. Okay. Okay, and now we need to do the distance and pixel coloring operation. Yeah, like this is kind of like, this is as simple as I wanted it. I don't know. It takes time to get to these things, what can I say? In retrospect, it's all simple. In the moment, it's not. So now we want to do like the distance calculation. So let's say like the pixel distance, or just like distance, that's fine. So the distance is now simply I squared plus, yeah, there's no way getting around that, I squared plus j squared, and that's it. And we want to, we can actually make this like a bool. So we can say like within disk. And we want to compare this to the radius squared. So we want to say, is this thing less than or equal to, do I need to put parentheses around this? I don't think so. Is this less than or equal to the radius squared? And then if it is, it will be like a 1, otherwise it will be a 0. So now we want to say, we want to set a color. Actually, we don't even need to do that. We can just like, we will only write it if it actually is within the disk. So see if it's within the disk, we want to color the pixel. And then we want to say dereference the pixel pointer and set that equal to the color. And then I think that's all we need. Okay, that was like way easier than, yeah, than what was there previously. Okay, let's just go to all this. And this is like, this is the kind of thing I can translate into assembly and not get a migraine from. The diamond thing, that was going too far. All right, I should read through this again. Catch any bugs here. Okay, so yeah. From I equals negative radius to radius, add 1 each time to it, get the pixel pointer, which is just going to be like the first line position. So yeah, the y plus the I times the frame width, and then subtract from that the radius. Everything we're doing with we're dealing with colors, which are 4 bytes, multiply everything by 2. Then from j equals negative radius to the radius, each time increase it by 1, increase the pixel pointer by 4, determine if it's within the disk or not. If it's within it, color it, otherwise discontinue. Okay, that looks good to me. So now let's try and draw the disk. Draw a disk. And then we'll make the radius like 10 or something. Actually, let's just have like, oh, this was the buggy loop. We'll draw several. Prolata. I add 1 to it. won't worry about this just yet. Draw disk. Let's draw this at like 400 and 300. And what should the radius be? Let's make the radius 10. And we'll draw it in light gray. Okay, let us compile this. Let's try and compile it. No, we don't want to compile the diamonds. We want to now compile the disk. Uh-oh. Forgot semicolon. There's always one of them. Let's see. Am I forgetting any other semicolons? Hopefully not. Okay, this is compiling. Let's see if it renders. Okay, and it has, and we can see the outlines of a disk on the side. So let's like center this and increase the radius. Yeah, I'm not sure why it's getting drawn right at the border. That was unexpected. So it is like drawn at the halfway point, but it's been shifted all the way over. Weird. Let's say I draw it at like 100, 100. And I increase the radius to like 20. Well, we'll look at drawn now. Wait, why would this be happening? I think it's because, wait, no, what? I think it's because I forgot to like factor x into the calculation of like the initial offset. Yeah, I need to like, we need to add in the x. But this is already a disk, so this is good. Let's put this. We can start animating the disk soon. Start getting this thing moving. Okay, so the draw disk. Yeah. We need to add in the x here and then minus the radius. Okay, that should fix that. And then we need to, let's like start moving this disk. So So let's what would be a simple-ish way of doing this? We can just try and bounce the disk around the screen. Oh, this itself. Without floating points functions, it's difficult to animate it in a circle or something. I wonder if I could just wrap it around the screen in some way. Yeah, it could be something where we just we give it some velocity and then we'll just make the screen a torus. Okay, so let's say S64 pos x, or maybe just x pos is better. The x pos can just start off at 0, and the y pos can also start off at 0. And really both of these should actually be set up before the loop, since we're going to be changing them. And then let's just add, let's add what, 5 to this. Okay, let's just, we may as well make this slightly better. Let's say speed, and we'll make the speed 5. Okay. I don't like the way that's aligned. Okay. We'll just increase this by, I'm going to do it anyway. We may as well have an x speed and a y speed. Let's choose two numbers that are relatively prime. Okay, we'll increase the x pos by the y speed, by the x speed, and then the y pos by the y speed, and then this is where we'll need to do the wraparound calculation. We need to check if the x speed and the y speed is greater than the screen. So if we're doing an 800 by 600 screen, we want to say if the x pos is greater than the width, which is 800, we'll just subtract 800 from it. And then similarly, if the y pos is greater than 600, then the y pos, subtract from it the 600. Okay. And then that will make it wrap around, and then we just want to draw it. So now instead of drawing it at 100, 100, we want to draw this at the x pos and the y pos. Okay, let us attempt to compile this. and then we'll get this moving. Oh, okay. Did something bad with the pointer. Curious. I didn't think I adjusted that many things. What's happened? Yeah, I'm really confused what's going on here. How could simply adding in these like loops like stop this up? Like, I'm so confused. Is like the bug potentially because like the X pos and the Y pos are both 0? This would be really weird. Let's say we start them off at like 1 and 1. No, yeah, I need source control. I need source control for this. Okay, let's like not call any of this stuff. Like, this is what it was before, wasn't it? Like, this should be fine. I'll be very upset if this starts failing. This stuff here can go, I think. We'll leave it here. Like I'm slightly suspicious that like the since like the compile time has like gone down, something's really wrong. Oh no, that's fine. Okay. What? How are we causing a crash with these variables? Like what? How? Like why is calling draw disk with these non-constant variables causing a crash? I don't understand. Like let's say I draw these at like 50 and 50. Like surely this wouldn't cause a crash. Okay, that's fine. Good. What could it be then? Can I just say xpos add 5 to it each frame? Like, I wonder if it was the if statements in some way. Okay, that's cool. The disk is animating. Okay, and it actually goes across the screen. Right, which is expected. Um, so yeah, why is this causing the fail? Um, like really? Like I wonder if it's like adding, like doing plus equals with another variable. Like I wonder if this is if this is causing a compiler crash. I would be, like it might. Well, it's not compiler crash if that's just causing like a runtime crash. Okay, let's see if it can handle this. Okay. It can do that. I reckon it is this plus equals example. So yeah, so that's like let's wrap this stuff. I'm like, the if statements are not like that buggy, but this stuff here. And I can send this to Sam. So yeah, so we want to say the x clause plus equals 5, and then the y clause plus equals like 7. And then do those things. And maybe Sam already knows about this issue. Maybe not. I don't see it moving up and down. Why not? We did compile it, did we not? Okay, great. Oh, okay. Okay. Maybe this is explaining why it failed. We can get around this by simply not, by like drawing the disk within like some safe bounds. So okay, I think this explains it more. Like because like when we're drawing this disk, if we're like, when we go like backwards, if we were like drawing it outside of like the acceptable boundary, it was just failing. So I think if anything, we should have added in like an extra check that said, take like the maximum of like the left and the right and like draw stuff from that, but it's fine. Let's add like a buffer of, I kind of want to make this a bit bigger. Where should we begin this buffer? Let's just have like a border of like 100 around everything. And then whenever the position gets above like 600, that is, it's like it's crossed the other border, we then want to subtract from it 700 really. And we want to subtract from it 600. And likewise here, the border is like 400, so now if it ever increases above 500, subtract 400 from it. And let's also, I want to try and increase the frame rate. Let's see what this is like on like the mode 3. Oh, like the frame rate is plummeted. Okay. Which is a bit surprising. Like I'm still a bit unclear as to how. As to like what the bottleneck for displaying pictures are on this. Okay, so maybe upping the resolution to that is a bit ambitious. Never mind, we can lower it down. So we'll move it back to this. And yeah, let's draw like a couple of disks. We'll get rid of this unnecessary loop. And we'll have like xpos 1. Let's have like 3 disks. We'll make them like red. We can make them like magenta, cyan, and whatever the other is. Yellow, I guess. Okay. We'll make all of these go in different directions. I suppose we could alter the size of them in some way. Maybe we can make them like 15, 20, 25. Okay. And then we want to define the colors, so let's do, well, what can we have? Instead of light gray, let's have kind of magenta, cyan, and then yellow. Okay, and then like the endianness of everything means that like the last two digits are the blue. So if we want cyan, that's like blue and green. So you so I guess we can keep this like FF FFF00. Then for magenta we don't want blue. I mean we don't want green, so we want that FF00FF. And then for yellow we don't want blue, so we want 00FF. Okay, and then so we'll check this out before we send a report, but I think uncommenting this thing is causing the crash. Oh, actually, maybe it's not. Like, maybe it's... No, I think it is actually fine. It was like the thing when we were like... It was the weird reads that we were doing that was causing it. I think. We'll get rid of the speed stuff. Maybe we'll set this at like 200, 200, 200, 200. And then I want to animate these. Let's like change up these numbers. Maybe that's like 11 and 2. And this one can be like 9 and 4. Okay. Let's compile and check it. Hang on. We need to actually use these colors. Like this magenta, like this cyan, like this yellow. Idea. Don't know x plus 2. Really? Line 121. Oops. I still feel like it's good to have this in here. We'll move this to the bottom. And we'll wrap this up as well. Let's just call this disk. All of this should be moved up as well. I feel like the steps to compile the program should be at the top. Okay, we can do all of that. Okay. Back to the compiler. No, why did I do that? We just want to write, I want to just check it out. Aha, great. This is moving very quickly, but that stuff is getting drawn. Okay. This is moving perhaps too quickly. Like maybe another option that could be fun is actually to not clear the frame each time. Like that could kind of be wild. Okay, but okay, we wanna slow down the disks because they're moving a bit too quickly. Yeah, and then what I want to try and do is disable the draw the entire rectangle again. So I think this will have like a cool effect. Okay, so let's like do 2 and 3 in the first case. And do 5 and 3 in the second case. And then maybe like 3 and 7 in this case. Okay. Let's compile. Okay, yeah, cool. This is what I thought would happen. Okay, and I'm generally happy with that. Although, like, I think this would look more interesting if we had them like not necessarily going in positive directions, but kind of also like maybe one can like we'll have them like going in like three different directions. But this looks cool. This is Discord shareable worthy. So yeah, let's get these moving in different directions. So let's have one which is going, that's traveling southwest. Let's have one that's kind of going northwest. So let's see, for that case we'd want to subtract that. And then the other one can be heading, maybe we can even make it like slower. Maybe just 3-2 is fine. In that direction. Okay. Oh, I don't think I even saved that. Okay. Okay, save. And we'll compile it. Okay. Oh no. What? I thought we had our like safety bounds checks. Oh, I see. Because now, like, because we're decreasing numbers, we need to deal with that. It's like it's instead of just like. Okay, so really what I want to say is if xpos, oh no, there's like so many things to add in now. I guess we can actually we don't need to add anything, we just need to alter these. Okay, so xpos 1 is always decreasing in this. This is such a contrived example, but it's fine. And to make them like stop popping weirdly, we might just make the radius like we made like the radius. We can copy these. Let's make this like 17 and like 21. Okay, so we'll make this like the border 50. And we're doing 800 by 600. So xpos 1 is decreasing. If it ever gets beneath 50, we want to add to it 750. Is this too much? No, we want to add to it 700. Ypos 1 is increasing, and so if this gets above 750, we want to bring it back down by no. It's above 550. We want to bring it back down by 500. Xpos 2 is increasing. So in this case, if it gets above 750, we want to bring it back down by 700. Ypos 2 is decreasing. So if it gets below 50, then add to it 700. X pos 3 is, both of these are always increasing, so we can kind of almost keep these the same. Only now the border's changed, and here if it gets above 550, then subtract 500 from it. Okay. Okay. Let's just see if I didn't make any mistakes in this arithmetic, which is probably asking too much. Okay, and it hasn't crashed. Great. Cool. I could probably do something where the colors themselves like begin to change, but maybe that's like too much. I don't think these are moving at a fast enough speed. Now I look at it. Like I like how fast the blue ones are moving, but the other ones are like too slow in some way. There's like so much jittering going on with the screen as well, which is unexpected. Okay. Let's adapt that. So like the Serenum was going, like the fast one was going. The 3 and the 5 was great, the 2's not so much. So what if we do like 3 and 7 and do 7 and 5. Okay. So I'm not sure I saved that. Okay, great. This looks better. This is more what I was thinking. Oh, oops, we've made the we've chosen multiples of. Okay, what's happening with the magenta here? Something's going wrong. We're getting some like weird multiples happening. More magenta is needed. Okay, so oh yeah, because the 7 and the 5, of course, we're like, it's like 700 by 500 is like the thing. So of course this is gonna wrap. Let's do like, oh, what if we did like 4 and 8 wouldn't work. But like 3 and 8. Uh-oh. I feel like I've got a system crash. Oh no. Things are not being responsive in this window. Okay, let's like, I'm gonna like kill the Serenum power. And then we'll reboot the system. Okay, great. Okay, let's navigate back to the RISC-V drawing experiments. Now we want to compile the codecs with a disk.lbc, and we're writing that to the productor disk.pb. Okay, great. That's more what I wanted. Okay, yeah, I am happy with this in terms of like a stream today. So, yeah, I think I will, yeah, let's make a copy of this now. This like, I think this looks pretty fun. I can figure out how to do that. So let's get rid of GIMP, and then let's Control-Alt-Delete that. Kill that. I think, can I do this like snipping tool in order to like, let's see, maybe I can like, unless there's some like, oh, there's some like automatic recording this. Oh wait, I can just press this like button down here, I think. Okay. Well, where's it gonna get saved to? Well, let's just test, right? If I, like, where did that just get saved to? I didn't see it appearing on the desktop. Is it in videos? Unable to open the file. Okay. Whatever this custom software is, it has failed. So let's go back to this crude ability. Okay, we can do start. I think that's enough. We'll do like 15 seconds. Okay. And then where do I save this? I automatically save to the screen recording folder. Okay. And where exactly is that? Is this also in videos? Okay, it is in here. Cool. Call this like Serenum disks. Okay, and then okay, I can post this to like the Discord, which will be fun. Right, this is like, that's fine. That will be fine. Okay, I should. Let's see. I'll make like I know like off stream. I'll make a copy of. I'll post like a copy of this disk thing to the Discord, so people can, and other people can play around with it. And then I think next time in the future, we'll then try and get the, why is this not full screen anymore? We'll try and get the code into like RISC-V. But yeah, that's it for me. This was good. Yeah, we did some beginning with the diamond. That was too complicated, but we drew a disk. We figured out how to do it in a simple way, and yeah, next time it will be, I mean, let's just even see what it is, right? Next time, getting this into assembly will not be as hard as if we tried doing it with the disk thing. Like this is like a modest amount of stuff to translate into RISC-V assembly. Yeah, there's just like, there is 2 loops, but in terms of the calculations, the complex calculations, like 1, 2 complex calculations, 1 like branch, and even like this branch there might even be some way of like, there would be a simple way of doing this in assembly. Like we could even just check that it's like greater than the radius, and if it's greater than the radius, like begin the next loop immediately, kind of jump out of it. But yeah, we'll work on translating this next time. But otherwise, thanks to everyone who stopped along and said hi, and yeah, happy programming.